have a bit of a look at trying to describe the transformations that have taken place after we're given that one function's been moved to another. I think a nice way of doing this is to rewrite each equation in terms of where we started. So the left-hand side, y equals square root of x. The right-hand side, let's write it as y dashed is equal to negative square root of 2 minus 3x dashed plus 2. So what I'm looking to do now is to rearrange that right-hand side so it's something equals square root of something. So in other words, y dashed minus 2 over negative 1 is equal to the square root of 2 minus 3x dashed. So now I can equate my y and y dashed, x and x dashed. So if you like, this y value here, so let's go here, this point xy has become, just change the cover, well the x value is 2 minus 3x dashed, the y value is, let's write it as negative y dashed plus 2. Okay, so now I can equate, I'll leave it all in red, so x is equal to 2 minus 3x dashed, y is equal to negative y dashed plus 2. So now if I transpose, I get x minus 2 over negative 3 equals x dashed, y minus 2 over negative 1 is equal to y dashed. So now if I just concentrate, let's maybe multiply, tidy it up a bit, let's put it minus 1/3 of x minus 2 equals x dashed, and we'll just say, what if we go 2 minus y equals y dashed. So they describe my transformation. So now my new point is minus 1/3 x minus 2, 2 minus y. So how do we make these transformations? What statements describe these transformations? So let's have a look at the x coordinate. So my series of transformations, if we do it, in the order, the first thing that's happened is we've moved 2 units in the negative x direction. So translate 2 units in negative x direction. And so then the x value is being multiplied by a value of 1/3. So it's been dilated by a factor of 1/3. Now if the x value is multiplied, it means it's from the y-axis. So 1/3 from y-axis, and that negative on the x, and so it's been reflected about, well, if the x value is made negative, it flips it upside down. Sorry, it flips it around Beyonce style. So it's about the y-axis. So it's reflected about the y-axis. So those black statements there refer to those things there, okay? If we now just change our cover, so what are the y translations? Well, the y value had 2 added to it, so it's been translated 2 units in positive y direction. Now, the negative y value, actually, we probably should have done that order. Let's do that step second, because we've had to reflect about x-axis first. So you have to do that first. In other words, we had xy reflected about the x-axis, it became x negative y, and then we've translated 2 units, which is the statement that we've got. If I do it the order I've just written it there, I'm going to have x, y plus 2, and then if I do the reflection, it becomes x negative y plus 2, which is slightly different, isn't it? So let's be careful. So let's really emphasize that. Maybe a different pen. So that's the first transformation. That's the second transformation, okay? And both of those in blue, they just describe what happened to the y value. All right, so it's a little bit involved. You've got to take it a step at a time. Let's see how we go with the next one here. So we're going to have, let's start with y equals x cubed. Let's split our page a little bit in case I need more room. And the other one, let's write it as, well, y dashed, let's subtract 4 equals 2x minus 3 all cubed. So now we can equate our two expressions there. So we can see that, if you like, y is going to be equal to y dash minus 4, excuse me, and x will be equal to 2x dashed minus 3. So this one looks a bit more straightforward. We'll get y plus 4 equals y dashed, x plus 3 on 2 equals x dashed. So my point, x dashed y dashed is equal to, let's write it as a half, x plus 3, comma, y plus 4. So again, looking at those things there, I'm going to do x plus 3. So it's translate 3 units in positive x direction. And then I'm going to dilate by a factor of a half. Dilate by a factor of a half. Just got to think about which axis. So the x value gets multiplied. So if I come up here, if the x value gets multiplied, I shrink, everything shrinks in, which means then it's going to be a half from the y axis. And now I'll use that one there. If the y value gets a value of 4 added to it, we simply translate by translate 4 units in positive y direction. Okay, so there's the transformations that took place on that one. Okay, so let's have a look. Same principles. The original function was y equals 1 on x. The new function, y dashed, is equal to 3 over x dashed minus 2 plus 2. So rewrite that right-hand side to fit that form. So we get y dashed minus 2 over 3 is equal to 1 over x dashed minus 2. So now if we equate our x and y values, we can see that y would be equal to y dashed minus 2 on 3. X will be equal to x dashed minus 2. So it'll rearrange 3y plus 2 equals y dashed, x plus 2 equals x dashed, which means my new point is given by x plus 2, 3y plus 2. So add 2 to the x value. So if I add 2 to the x value, we translate positive x direction by 2 units. And then what's happening there? Well, let's do our 3 times y first. So what's that means? We're going to dilate by factor of 3 from, now the y value is increased by 3, so we're stretching up, so it's from the x-axis, and then we're going to shift 2 units up and translate 2 units in positive y direction. Okay. Scooting straight along to B, it's a long one. So again, y equals 1 on x, and we'll have y dashed, let's take a shortcut, plus 1 over negative 1 is equal to 1 over 2 minus 3x. Okay, so now if we rearrange a little bit, y is equal to, let's put negative y dash minus 1, x is equal to 2 minus 3x. That's just there. So if I y plus 1 over negative 1 is equal to y dashed, x minus 2 over negative 3 is equal to x dashed. So my new point is the x value. Let's make it minus 1/3 outside of x minus 2, comma, well, let's just make it minus y minus 1. So now, again, let's just list those transformations. Let's go to black. So we're going to have 2 units to the left in negative x direction. And then we're going to, let's dilate by a factor by 1/3 from x value, so it's the y-axis. And then we're going to reflect about, so again, the x value gets made negative, so it flips upside down. Sorry, the x value gets made negative, so it's reflecting left to right, so it's about the y-axis. We made that mistake twice, so be careful. And then in here, well, let's reflect negative y, so we reflect about the y value gets made negative, so that's about the x-axis. And then we move 1 unit down. Just move 1 unit negative y direction. Okay, so take your time, have a good go at those, and let's talk about it in class.